77 referred journal and conference papers of international reputed including SCI indexed and Scopus indexed journals like Applied Soft Computing elsewhere and Applied Intelligence Springer, each of which is a peer-reviewed journal. He is a senior member of IEEE and an active member of ACM, CSTA, and other scientific societies. He also reviewed papers for many scientific journals and conferences in the US and abroad. He led keynote speaker sessions at various IEEE, ACM, elsewhere, and Springer conferences. He also delivered expert talks at various reputed organizations such as DRDO, Delhi, ATAL FDP, SPIT Mumbai, Aaron College MP, and Satyabhama University Chennai. He is currently supervising 3 PhD students. He is the co-principal investigator of 3 major research projects. He published 5 patents and he also published several books chapters for Springer, Ville, Elsewhere, and CRC. He is also the co-editor of 4 books under Taylor and Francis. So please start your session.
Umesh, kindly unmute yourself.
Am I audible?
Yes, you are audible, Millie.
Am I audible, ma'am?
Yes,
Yeah,
sir.
yeah, Umesh.
Yeah. So my screen is visible to you?
Yes.
Yes, sir. Your screen is visible.
Okay. So shall we start?
Yes, you start.
Sure. Okay. So good evening, all of you.
Good evening,
As
Umesh.
Millie ma'am
Good evening,
already
sir.
introduced, yeah. So Millie ma'am already introduced me, and it's my highly privileged to give this FDP session on generative AI, mastery from foundation to application. First, I thank to Dr. Nitin and Dr. Shivani, so who invited me for this FDP. So then we can start with the topic of training challenges in GAN. So as last session already taken by Mr. Ane, and he already discussed about generative adversarial network. So one of the participants already asked the question, what are the challenges in GAN? Because I was, I joined that session in between. So that time I listened that, a question. So one of the participants asked the question. So that time sir have answered for 3 challenges. So I will explain those 3 as well as more than that. So we can understand what will be the problem for GAN. So these are the outlines of the presentation. So directly jump to the training challenges. Before that, I can start with generative AI, because the FDP theme is generative AI mastery foundation to eco mastery to foundation to application. So generative AI refers to, we know that advanced AI, you can say advanced AI intelligence system capable of creating new original content such as images, text, audio, and video that are closely resembles to human generated data. So before that, when we are discussing about AI, so when we talk about in the old days, so that time AI was used in, like you can say, the path searching algorithm, hill climbing algorithm, A-star algorithm. After that, we have used machine learning algorithm. Then we have used deep learning algorithm. And now it's the era of generative AI. So you can say, like, these systems are powered by machine learning techniques. Whatever we have encountered in past 20 years, so those techniques we can use here. That will model the complex data distribution and enable them to produce novel and realistic output. So before that, what we are doing, we were just apply the data set and we get the solution. But in this time, we will get the new solution, or you can say the new images. So that terms as new generation. So here we can say the generative AI bridges the gap between human creativity and computational efficiency. Or you can say it will drive the innovation across diverse industry. It's not only related to the healthcare only or the manufacturing sector only, or there are number of sectors where we can get the different innovations. Am I audible? Ma'am, am I
Yes,
audible?
sir. Yes, sir.
So I don't want to be a like because the online session, we know that, as we know the culture of online session, we just joined it and do the our personal work. So my suggestion is we can interact in between and we can discuss so many things. I think my screen is stuck over there. Wait a minute. Yeah. So when we talk about generative AI from last 2 days, what we have understand, there are number of key technologies for generative AI. So start with the GAN, then by you can say tomorrow we will go with the variational encoder, then next day we will go for the transformer and then diffusion model. So we just understand the notion of key technologies of generative models which will use for generative AI. So first is GAN. As Mr. Ane already explained, that a system with two neural network. One is generator, another is discriminator. And it is in a zero-sum game to generate realistic output. So may I ask to the participant, can anyone tell what is zero-sum game? Yes, anyone? It will be wrong, but that will be okay. You can guess. Yes, anyone know about zero-sum game? Anyone? It's not a, it doesn't matter like whether you are correct or not.
Yeah, maybe it is where only one of the side is winning the game.
Okay. Okay, I will tell. Yeah, any other guess? Because when we don't know, we have to guess. At least our mind will work. Otherwise, it will be in the in the idle condition only. Yeah, any other one? Because we recently just introduced with GAN by Mr. Ane.
One is generating and other is identifying by the Mitrakshi Patil.
Pardon, ma'am?
Mitrakshi Patil ma'am said one
Mhm.
is generating and other is identifying.
Okay. Any other? We have more than 90 participants. So
Yeah,
anyone
any
can
other
speak.
participant, please answer the question.
It's not a question. You can participate at least. Otherwise, you will feel bored.
Yeah, definitely.
I'm simply asking like, what is zero-sum game?
Yeah, question is what is the zero sum game? So
Yeah.
please answer the question to Dr. Umesh.
Okay.
Equal number of losses and gains by the
Okay,
Anjali
Anjali
Sardana
Sardana.
ma'am.
Yeah, okay. So one said that one team is playing or winning. Someone said that, you can say equal number of gain and loss. And Mitali ma'am said that, like, we have a generated sum and something. Identifying. So, yes. So we can say Anjali ma'am is correct. So when we talk about zero sum, so please understand the simple example. Suppose your mom have prepared one dish like poha, okay, and along with the milk they have given. So we have two kids. So one kid is eating poha, another like milk only. So when they both sit together, so what they will do? So either one will finish the poha, then milk will be remain same, or the other will finish the milk, the poha will remain in the plate. So what will we do? What they will do? They will do one game. So that time the total sum will be zero. That means you have to finish the milk and you have to finish second person will finish the poha. So that time the sum will be zero. So when we talk about the generator and discriminator, so as Mr. Ane already told that generator will generate fake images and discriminator will identifying fake images. So now it is a one-to-one mapping. Means how many images will be generated by the generator as a fake image, and how many images will be identified or recognized by the discriminator. So that time it will be a balanced thing. So that is a zero-sum game. So hope you understand the example. So a system with two neural network where generator and discriminator is there in a zero-sum game, and to generate realistic output. So when we talk about generate realistic output, can someone will say what is the meaning of that? Anyone? What do you guess? Yes, anyone, please?
I think kindly
Yes.
repeat the question.
Yeah, yes. I am. My slide is already shown to you, ma'am.
Yeah.
Yeah. So in the first technology, that is GAN. So I'm just reading the definition and just explaining the words. So we understand the system have two neural network. One is generator and the discriminator. Then second is it's a zero-sum game. We understand that. Now the third one is to generate realistic output. What is the meaning of that?
Sir, either in 0 and 1 in a binary form.
Okay. Same as real. What I think.
But not real actually. By the Anjali ma'am.
Okay. But not real. Yeah, any other? So here we are talking about to generate realistic output. So realistic output means we can say, suppose generator will generate a fake image, and that time discriminator is unable to identify that image. You get my point? That means it will be similar to the real image.
Like image and text.
No. For example, we have seen a lot many animated videos for Lord Ram or Lord Krishna. Okay, but we haven't seen Lord Ram, Lord Krishna, the actual pic. Okay, but we have passed number of text in terms of context, number of text, and we get some video, some images. Okay, so that look like the realistic output when we are relating with the text. Am I understandable for this thing?
Yeah, now I understand.
So now the second technology is variational autoencoder. That means we are encoding the data in the latent space and reconstruct it to generate similar content like kind. So there are some challenges for GAN where it will fail. So we just shift it to the autoencoder. Then there is a variational autoencoder. So we will explore by tomorrow. And third is transformers. So there is an advancement in in the deep learning order. As someone already asked one question to Mr. Ane, we have a image data and we have different kind of healthcare data. So how can we apply GAN for those data set? So that time Mr. Ane already told that we can go with the autoencoder and transformer. So similar like the number of models for transformer, you can like GPT that generate text by predicting the next word. So it may be correct, it may be wrong, but the transformer will try to do as much as similar to the inline with the whatever we pass that word. And last model is diffusion model. So where we go with the reverse noise process to create high quality images. That means you can say DALE. That image is not there. For example, you want a person will sit on a chair and the chair will be on the back of a horse. You simply pass this text to the DALE and it will create an image. So that time DALE will give you that image where a horse will be there. At the back of the horse, one chair will be there and one person will be sit. Suppose your mind said that I will be sit on the moon and eating ice cream. So that time, whatever text you are passing to the, this, you can say the model, it will create high quality images for that. So these are the all key technologies for generative AI. So now, So these are the applications where we are using generative AI. For example, image design, image generation. When we talk about the videos, so you can edit the video generation, sales, marketing. So these you can say the circle will give you the all apps, whatever symbols, whatever logo you are seeing in this image, you can directly open that. It's a freely available, and that's also paid version is also there. So you can generate various text for marketing. There are number of you can see copy.ai. If you are in research, so you can use DeepMind or stability.ai. If you want to do something with speech or wave kind of file, so that time you can with the podcast.ai. So like that, if you are dealing with the code, so that time you can do various documentation with Mintify or text to SQL by using Seek or code generation. You can say by GitHub Copilot. So the number of apps are available for generative AI where we can deal with these apps. So it's a landscape, application landscape for generative AI. So now the first topic is GAN, because as we understand about the generative AI, so GAN is a machine learning model. We know that. So as we understand machine learning, so there are two kinds of machine learning, or you can say three kind of. One is supervised learning, another is unsupervised learning, and third is reinforcement learning. So generally GAN will be considered under the unsupervised, you can say. And under this, we are running two neural network that are competing each other to become more accurate in the prediction. So either generator will more accurate or discriminator will more accurate. So that time they are using cooperative zero-sum game. We already discussed this thing. And two neural network that make a GAN, generator and discriminator. So this is the structure of a GAN. For example, we are passing some random inputs over there to the generator. It will generate fake images. Then the fake image will pass to a discriminator, and with the matching with the real images, it will try and will give the discriminator loss as well as the generator loss. So here you can say we understand the basic terminology of GAN is discriminator and generator. But what is the new thing behind that? If we already have the deep learning model, the new thing is loss function. So here there will be updation. Whatever discriminator will, for example, just understand, we just pass one image, one fake image to the discriminator that is generated by generator, and discriminator is identifying only 10%. So that time that input will feed it to the generator, and generator will try to update that fake image. Then again it will send to the discriminator. Then suddenly discriminator will identify that image as a fake image 90%. That means in this level discriminator is winning and generator is losing. So then generator will again update the process and will generate more fake image. So like that they try to accumulate different discriminator loss and generator loss over there. So these are the following steps for GAN. First, generator outputs an image after accepting random numbers. Yeah, Abhijit Mishra sir, I will definitely give the answer. I will take the questions after this. Second, the discriminator received this created image in addition to a stream of photos from the real or ground truth data set, and that discriminator input both real and fake image. You can say the output probability will be there. So a value will be between 0 to 1, or generally when we normalize like -1 to 1, we can say. So where 0 or -1, you can say will be a fake image, and you will get the 1 that will be the, indicates the prediction of authentic or real image. So that will be a typical steps for GAN. So it is a, generator versus discriminator architecture. So here we are passing random noise to the generator, and that will be reshaping, then upsampling, then go to the discriminator side, and it will give you the output in terms of either 0 or 1. So where the GAN will be applicable? Now we understand GAN because we already done 2 hours with GAN. Now we have to go with the next applicability. So when we talk about GAN are mostly, you can say, associated with a generating image, what we understand from the last 2 hours. But I am telling one more thing, that is, it can be applied to text, audio, even video also. But again, it will be a difficult task. So when we talk about the GAN applicability, mostly it can generate new images based on training data. For example, faces or landscape, or you can say super resolution, where you can enhance the resolution of low quality images. You can use the GAN over there. As well as if you want to improve the style, you can improve the style, or you can transfer the style of one image. So that time you can also use the GAN. So like that, for example, in this image, you can see what we are doing. We are generating new images. Here we are passing to the, you can say, discriminator and generator side. So then if we are passing these images, and it will be the fake images will be there. So like that. If we are going with the, you can say, improve low quality images to the high quality, so that time we can go, you can see here the input, from the real life photos are there, and it will pass to different GAN, or you can say we can get number of improved, you can say, low quality to high quality images with the help of GAN. When we talk about the style transfer, so that time these are the content images and these are the style, and you want to copy these style into those content images. So that time the output will look like that. So here you can say you are applying on image synthesis, where content image will be here, style will be here, and you will get the, style is already transferred. Yeah. So am I audible? Everyone is with me?
Yes, yes, audible.
Okay. So now the first applicability I already told, that image. Now the second is you can apply it to text also, but it is more challenging. So we understand, like, the primary difficulty will be the nature of text compared to the continuous image. So here, like, what you can do with the text, you can generate text generation or text to image generation. But again, when you are going for text generation, that means you are passing an image of text, or you can say the text to image generation again. Simply, you can also generate realistic audio clip, or you can say like speech generation or music generation. But again, I'm saying GAN mostly used for images, but here for animation videos, or you can say you can generate realistic video clips from some initial frame. It will guess the next video frames. So you can do with the GAN also by changing the loss functions. So when we do experiment on GAN, so that time what we will do, I will share one collab file with all of you, and we will understand like how the GAN program will run. So we first do the setup, because we will do with the TensorFlow here. So set up, load, and prepare the data set. Then we will create the model, like the generator and the discriminator. So we'll create those two models. Then define the loss function. Which loss function you are using? Generally, we are using cross entropy loss function here, and optimizers. So you can say like Adam optimizer we are using in the deep learning. So discriminator loss and generator loss, we will define these two in respect to generator and discriminator. And next we will define the training loop, where we are passing this discriminator and generator. Then we will train the model, and you can create the GIF if you want. It's an optional step. So before running the program, I don't know like what is the the audience knowledge. So everyone know about the activation function? Yes, anyone can say, apart from coordinators?
Yes, yes. Yes,
Okay.
Anjali Sardana ma'am say yes.
Yeah. So I'm not discussing about the linear activation function, but these activation function will use in GAN. So that's why I have just written, and we just touch little bit about these activation function. So first is sigmoid activation function and logistic activation function. So we can say the graph will be look like that. and the output value, you can say between 0 to 1. So normalizing the output of each neuron. We know that the deep learning neural network architecture already, it was discussed by various, the previous, you can say invitees. So, and it will go for the clear prediction. For X, you can say above 2. Here you can see, or below -2. It tends to bring the Y values to the edge of the curve. That means it is very close to 0 and 1 or 0 like that. So it will enable the clear prediction. So sigmoid function is very useful, and you can use this function for input layer, sometime in output layer also, as well as for the hidden layer also. So various convolution layer, you can also use sigmoid function. But there are some disadvantages of sigmoid function. Why I'm discussing this? Because we are, our topic is challenges in GAN. So one of the challenges is vanishing gradient. So please be understand. So when we are using sigmoid function, that means for very high or very low value of X. X means input values, you can say. So very high value of X or very low value of X, there is almost no change in the prediction. That means the peaks will be disappear. So that causes a vanishing gradient problem. So vanishing gradient problem means whatever first gradient, any first differential you will get, that will be vanished. That means the value will be almost same to the previous step. After calculating the gradient, you will not get, that gradient over there after calculating any partial differentiation or differentiation. So that time it will result in a network to refuse learn more, because it will say the output will the previous one, and it will not go, in the next step. So that time you can say it will be too slow to reach the accurate prediction. So that, the sigmoid function will suffer with the vanishing gradient problem. The second problem with this activation function is here outputs are not zero centered. So you can see, so that's why, we have to be understand when it will be zero centered, that time you can say the gradient will be more, and it will be a computational expensive activation function. That means we have to understand those activation function will not be useful for us, where computational cost will be increased. So we have to move to the another activation function, that is tan H function. So here H is hyperbolic, you can say. So here is, you can say, the making easier to the model input that have strongly negative, neutral, or positive value, because zero centered. What was the problem with the sigmoid function? Otherwise, it will be same as the sigmoid function, and the formula we already know that. So tan H, you can say hyperbolic tangent function, activation function will be same as sigmoid apart from the zero center. But it is also facing the same vanishing gradient problem. For very high value or very low value of X, again, there is almost no change in the prediction. So this, you can say the learning will be very slow, and the computational, obviously it will be computationally expensive, because when the learning will be slow, that time it will take more time. It will be computationally overburdened on the, you can say. Third one is the ReLU function. So ReLU function, again, you can use an input layer or, any convolution layer, or you can say hidden layers. It is computationally efficient, whatever problem we are encountered with the sigmoid and tan H, because it allows the network to converge very quickly. So where convergence will be very quickly, that time, obviously it will take very less time, and you can say the problem is resolved. Although it looks like a linear function, you can see the graph. So ReLU has a derivative function and allow for backpropagation also. So backpropagation, those, I think so, everyone know about the deep learning. So that means backpropagation, when we are going the forward pass, and again we update the weights to the different neurons. So that time we go for the backpropagation. So here the formula is ReLU is very simple, like we are considering all the positive value, and the least value will be 0. So that time we will get all the positive value, and easily, you can see the graph also. But ReLU function have a problem, that is known as dying ReLU function, you can say. That means when an input approach to 0 or you can say any negative value. For example, x will be 0 or negative value. So that time the gradient function will become 0. So that means the network cannot perform back propagation, cannot learn before, before this ReLU, tan H, or you can say sigmoid, we are suffering with the, you can say, 2 small step learning that time. But here we will be stopped if we get any negative value or 0 value. So that time the ReLU will die. So you can say the next activation function which improves this ReLU problem, that is leaky ReLU function. So please remember this leaky ReLU. It will definitely work with GAN also. So it will prevent, you can say, the dying ReLU problem. What we are done, we change the formula. Before that, we are considering like 0, x. What will be the maximum value, and least value will be 0. But here we multiply with the, you can say, this 0.1, or you can say any variation we can take into x. So that time, the small positive slope in the negative area, it does enable the back propagation. You can see the graph. It will not end up to the 0 only. It will go towards the negative side also. So even for, it will work for negative input value also. Otherwise, it will be same as ReLU, but whatever we have changed, so it will work. It will definitely work for GAN also. So generally in GAN, we use leaky ReLU function. But the problem, you can say, results are not consistent. It will not give you the consistent prediction. That's the problem of GAN also. So it is a challenge. So for negative input value, again, it will not give the consistent prediction. So now we are going through the training challenges in GAN. What are the training challenges? Now we understand the activation function. First we discuss generative AI, then we discuss GAN, then we discuss discriminator and you can say generator. Then we discussed where it will be applicable, and then activation function. Now just go to the training challenges. So number 1 challenge is mode collapse. So when we read this word mode collapse, that means suppose a generator produces limited variety of output. Limited variety of output means, like for example, just one or a few mode of data distribution. The data will not be distributed in a variety. That means even if the real data has more diversity. For example, if generator will not produce a will not produce a variety of output, that time what will happen? Obviously, discriminator will win. That time, discriminator will easily identify these are the images. For example, I have passed 1. Suppose we have a number data set 1, 2, 3, 4, 5, 6, 8, 9. I have passed 1 to 9 images to the generator, but generator is generating only a fake image of number 1 only. So every time discriminator will easily recognize the the number. So you can say it will be similar look like the, you can say, the previous images, and discriminator easily classify as real. So leading to the generator producing the same output repeatedly. So what will be the solution for these mode collapse? You can say you can use mini batch discrimination. That means when you pass it, it will be, we have a batch normalization we are using in deep learning. So that time we can use over that. Or you can use unrolled GAN. Unrolled GAN means you just change the loss function. We are using binary cross entropy loss function over there. Or you can use the advanced architecture like WGAN, so which will help to prevent mode collapse. So here, if you are using WGAN, it will also enable the better convergence, and you can say it will handle mode collapse and generating more diverse and realistic sample. So that's the problem, because mode collapse was there. So we can see the this example here. After iteration 1, we get this this image from the random noise. Then for 100K we are getting this, for 500K we are getting this, and for 1000K we are getting this. So you can see all the images are almost same. So if we are using WGAN, so that time it will change like that. We are applying on amnesty data set. So that time it will improve, it will give you the diverse data set. Yes. Everyone understand till now? Yes or no?
Yes, sir.
Okay. Now the second problem with the GAN is you can say during the training time, vanishing gradient. We already discussed vanishing gradient in the sigmoid as well as in the you can say tan H, but it was solved by ReLU. But it was failed for negative values or the zero value. So that time it was handled by leaky ReLU. So again you can see when the gradient passed to the generator or discriminator becomes extremely small. Obviously it will be small, so that means it will be leading to the slow learning or you can say no learning. So it usually occur with the when the discriminator become too confident. ये कब होता है हमारे पास? For example, generator will generate the image, fake image, but discriminator is too confident to distinguish with real and fake image. So that cause generator to receive little or no feedback, because it is whatever feedback will be given by the discriminator to the generator. That time generator will will do the updation to generate the fake image. But if the learning is very slow, or you can say the discriminator is very too much confident, so in that case it will not give any feedback to the generator. So that time generator will not improve, and that time vanishing gradient problem will occur. Or you can say it will very frequently the discriminator is trained too well. So we already discussed GAN. It's a zero sum game. But suppose someone is too trained, too well trained. So here if discriminator is winning, so that time it will distinguish like real image from the adversarial image. In that scenario, what they will do? The training step of the generator, again back propagation is very low gradient, and it will not help to the generator to learn or you can say generate fake images. So in that case, we understand it is a vanishing gradient problem. So we have to apply leaky ReLU activation function over that in the discriminator basically. Or the second option is WGAN, that will mitigate or remove this issue and also ensure that the discriminator generator are balanced in their learning rates. Because if someone will be too trained or someone will be the fast learner, so that other will lose. So we have to take care with this, because there will be trade-off between discriminator and the generator. Here you can see the example. So in the left hand side, we have a the JS convergence we have applied. So meaningful gradient region is there, but after that the gradient region is vanished. So that time it will be vanished. That time you can say the problem will occur, and there is a problem with the training, and the GAN will fail. Or in the second graph you can see after 1 epoch, after 10 epoch, after 25 epoch, the gradient of the generator with the original cost it is showing. The training iteration is there. So you can see it will be stable only. So third challenge when we are discussing with the GAN training challenges, the first challenge we have discussed is mode collapse. The second challenge what we have discussed is, yes, anyone? The second challenge will be, if you are with me, yes, anyone? Can anyone repeat the second challenge what we have discussed?
Sir, vanishing gradient?
Yes. So one is mode collapse, second is vanishing gradient, and third is training instability. So training instability means, like you can say GAN are notorious for being unstable during time, because the adversarial nature of the training process, you can say it will lead to the fluctuating losses. Poor convergence will be there. Poor convergence means maybe it will be converged very fast, or it will be too late, or the oscillation in the generator and discriminator performance. So there will be instability over there, because generator and discriminator both are competing each other. They have to be balanced, so which can cause their losses to be diverged, or you can say oscillate. So if it will be diverge or oscillate, that time instability will occur. And that is the biggest challenge with the training, at the training time. If you will do some changes in one model, some change means like you are just, penalize some in an objective function, or you apply something, to handle the overfitting, apply the regularization. So that time again, it will destabilize the training of the others. So for handling this thing, again, the popular method is this WGAN you can do, or the gradient penalty over WGAN already, proposed to improve this stability while, gain train. And it will also provide a smoother gradient. So that time, vanishing gradient problem also not there. So it will, use alternate loss function are there. For example, Hoover loss we have a pinball loss function. So you can use those loss function also over there. So this is the example. We can see if we are using MLP like multi-layer perceptron here, the generator iteration is there. So that time we can see, and if we apply like MLP with the 512 neurons, so that time what will the instability over there? Left hand side will be the generation cost. The next challenge what we are dealing with the GAN is overfitting. So as we know that overfitting will happen obviously when discriminator becomes too specialized. The similar one, when vanishing gradient will happen. Vanishing gradient also happened in the same thing. When discriminator will be too smart or too well trained, or it will be too specialized at the distinguish between real or fake images, like on the basis of minor details. Or you can say rather than like generalize the detailed data, they just based on minor details also. That time you can say it is overfitting will be there. So in that case, you can say discriminator is too powerful. And it is also trained like for too many epochs compared to generator. So we have to take care for those hyperparameters, where we are, when we are running the generator and discriminator. So for handling this thing, we can use regularization method. So we have a number of regulation method like L1 penalty, L2 penalty, or elastic net regularization, or more than that. Or you can use like if you are using like dropout or early stopping, or you can also use data augmentation that will handle the overfitting, and it will generalize the model for unseen data. Otherwise, whatever data you will pass, it will be already trained. So that time it is already seen this data, and it will be too specialized for real and fake images. So like that, in the left hand side, we can see the number of epochs are there, and blue one is the loss, and the orange one is the F1 score. So we can see the overfitting is there. And the right hand side, we can understand the underfitting or just right or overfitting concept. We already know that when we are dealing with the underfitting, that time it is just a straight line like that ReLU function was there, and it will not bothering about how many points they are covering. So like in GAN, if our model is undertrained, so that time whatever fake image is generated by the generator, the discriminator will not identify that image, and the feedback will be always no learning. So that time you can say that this generator will generate, it will be well too trained, but discriminator will not. When we are going with the just right, that time that there is a complete trade-off between discriminator and generator. And when we are dealing with the overfitting, that time you can say yes, overfitting time, we can say discriminator will be well too trained. So it will based on minor details also. And the fourth one, you can say the challenge, or it's a fifth one, you can say hyperparameter tuning. So to find the right hyperparameter, like what are the hyperparameters? like learning rate. It should not be too small. It should not be too fast. The batch size, we have to understand what will be the batch size. For example, 256, we have taken 128, 64. So that time mini batch will be there, or the optimizer choice. For example, we are using Atom optimizer or the gradient optimizer, like that something, and the architecture configuration. So these are the hyperparameters where we have to be understand like which parameter is right for which kind of application. So it can take number of steps, number of epochs, so time consuming will be there. It will be crucial for training GAN. So GANs are very sensitive towards hyperparameters, and an improper choice can lead to the poor performance, or you can say unstable during training time, as we already discussed that in the third challenges. So we have to search carefully all the hyperparameter space, and you can use automated hyperparameter optimization method like grid search. You can use random search. You can use to find the optimal configuration, or you can go with the previous researchers already use what learning rate they have used, or you can run one loop and identify what will be the optimal learning rate will be there, what will be the adaptive optimizer that will improve your training. So that will be keep in mind how model collapse will be there, what vanishing gradient problem will be there, then hyperparameter tuning will be there, then we can say overfitting problem will be there, or training instability will be there. So these are the example for training challenges for hyperparameter tuning. So for example, in the first slide we can see the number of layers are 3, number of neurons 5 and 2, and learning rate is 0.1. So then run optimizer weight optimization will be, the score will be 85%, but you have changed now number of neurons and as well as the learning rate, then you will got 80% score. But here you can change the number of layers, number of neuron is 256, the learning rate is 0.1. It is a previous in the first one same as, then you got 92%. So we have to understand these hyperparameter tuning. That is the biggest challenge with the GAN. So the concluding remarks will be, training GANs require carefully balancing between generator and discriminator. That means both models are constantly trying to outsmart each other. So that time, if the discriminator will be too smart, that time you can say vanishing gradient problem will be there, or you can say training instability will be there. So then these training challenges can be addressed by either WGAN you can use, or you can apply gradient parallelity over there. Proper initialization should be there. Learning rate schedule will be there. Have to handle the overfitting, and as well as whatever adversarial setup you are using that drives the generator to create realistic data, as well as discriminator that learn to distinguish between real and fake image should is a fundamental challenge. If discriminator will not give any feedback or any feedback to the generator, that time again GAN will fail. So we will do this experiment. I'm just sharing this collab file with all of you. Should I put it on chat? Yes, Shivani ma'am.
Yes, sir, you can just put in on chat.
Wait a minute.
Yes, sir.
Where I have, I think so. Yes. Link doesn't match. It will not work. Can I send?
You just WhatsApp me. I will do it.
Okay. Or should I send the the collab file over here as an attachment?
Yeah, definitely. Or you have to send the link to me.
Okay, okay. I am just sending to you. Yes, Shivani, ma'am, you get it? Shivani, ma'am, am I audible?
Yes, yes, yes.
Or should I send the
No,
IP
no, I am
file?
sending the link in the chat box. Just a minute. Yes, I posted.
Okay.
Participant,
Otherwise,
please get the link from the chat box.
otherwise I have sent the the collab file also. You can send all the in the chat box also.
Okay, kindly send.
I have sent it.
Yeah.
Yes, my screen
Participant,
is
please
visible.
click the link. I already shared.
Yeah,
And it is
I have
asking the
shared this.
permission.
Pardon me. So that's why
Permission
I
is
have sent the.
required.
Yeah,
Access
yeah.
denied, sir.
That's why I have
Permission
sent the file
required.
also.
Yes,
I have
ma'am.
sent the file also, no, because it was uploaded in my collab file. Maybe. Okay, I can explain the code first. Then you can access from your side. Shivani ma'am will share the code with all of you. Yeah, my screen is visible.
Okay.
Shall
Yeah.
we start?
Yeah. You start.
Yeah, so we understand generator and discriminator. So it's a GAN code we are applying on Amnesty dataset. So you can see the artist A neural network trying to create pictures of cat that will be looks real. So apply to discriminator. So thousands of real images like labeled cat we have. And discriminator, we understand that the cat critic, a neural network. You can say the examining cat picture to determine whether they are real or fake. So during this training time, the generator progressively becomes better at creating images. So it will not be in the first time. Definitely, they have to give the feedback to the generator from the discriminator side, and it will tell them like whether they are identifying or not. Like if it's the first attempt, you can see the generator is there. It will generate like that through the random noise, and discriminator will say no, it will not identifying as a real or fake. Yes, that's similarly generator will do. You can say in the many attempts later, even more attempt later, the generator, whatever generate will. Yes, Nitin sir.
Yes, sir.
Yeah, should I wait?
Yeah.
Okay, okay.
Now you can continue, sir.
Okay. So even more attempts later, then it will identify, yeah, it's a fake image or real image like that. So now this notebook demonstrate this process on MNIST dataset. And the following animation shows a series of images produced by the generator. This animation, you can say, it was trained on 50 epochs, and the image begins as a random noise and increase resemble handwriting code digit over time. Like in the first time, second, third, like that, the 50 epochs, it will be trained. So first we are going for setup. So we import TensorFlow as TF. We have to check the version. So you can check TF dot underscore version underscore like that. And for generate GIF, you can go with the pip install image IO, or you can say pip install git plus like that TensorFlow or docs. So now setup is complete. Now you can import various libraries. For example, Globe. So why we are importing Globe? Because Globe is used to find all the path names, like matching with a similar pattern. For example, JPG file in a one folder that time, you can say like commonly applied for loading data set. And then image IO, we already explained that it was for reading and writing image data. So that time generally, useful for. Wait a minute. Yeah, something. Nitin sir, anything else?
Nothing, sir. Please continue.
Okay, I think you have sent something. That's why I was just okay. So now image.io we use for reading and writing image data generally, and here you can use for loading image into the Python project. Okay, and whatever you are saving the processed or generated image here. Then MATLAB plot, we already know that for plotting graph and all the images. Then NumPy, we know that. Then OS, we are importing for provides a way of interacting with the operating system, like managing files and directories here. Then PIL generally is a library for image processing in Python. Those who are working with image processing know that. And generally apply the task for resizing or cropping or manipulating any image data. That time we can use PIL. We are importing that library here. And TensorFlow time, that IPython. So IPython generally used to display rich content like images, videos in a Jupyter notebook. So we are importing display. Then second step we discussed already. That is, if we are going with the PPT, then we have 1 minute. Yes. So first step, we just set up, then load the data and prepare the data set. So we are going for loading and prepare the data set. So that time we are using MNS data set to train the generator and discriminator. And the generator will, generate handwritten digits that will resembling with MNS data set. It's a, you can set the numbers 1, 2, 3, 4, 5 like that. So we directly load the data set tf.keras.dataset mns.load_data. The data will be loaded here. So we just create train_image and train_label. That time now we are also using here train_images.reshape. So we use train_images.shape0 28 S type float 32. So that means this train_image.shape0, that means it's a number of training sample in the data set. And 28 1, that means we are reshaping each image to 28 to cross 28. We can say 1 grayscale we are converting, because we know that like 0 to 255 we have a, so that time we are going for that one. And here we are using float 32, that means it will convert the data to floating point. Then in the next one, what we are doing, we are subtracting 127.5 from the training image and divide by 127.5. That means we are normalizing the images to -1 to 1. So we are just going for, you can say, zero centered. That's the problem. We know that. We already discussed the activation function. So we subtract -127.5 center pixel value from, you can say, around 0, because we have a 0 to 255, and divide by 127.5. That means it will be range value -1 to 1. Okay, because as we know that the original pixel range will be 0 to 255, generally for 8-bit images I'm talking about. So after normalization, it will be look like that, like you can say means -127.5 to 127.5, and we divide it, so -1 to 1. Now we are defining the buffer size and batch size. So buffer size and batch size, like buffer size means like how much data you will be in buffer, and batch size like what data will be processed, you can say. So we divide the data set into batches. Okay, depends on what size we have considered. So it's again a hyperparameter. We have to be careful about that. Okay, and buffer size, you can say, like randomly shuffle the data set with the buffer whatever size you have considered here. So we will not take like too much high and not too much low. If you will too much high, so that time randomization is more. And when we'll take very very low, the size of buffer size, that time shuffling will not be occurred very properly. So that time it will not be well trained. So, and here we consider 60,000. That means the total number of training images in the MNIST data set. We have considered like for the buffer size. Now, the second step is create the model. So create the model means like first for generator model, and second is discriminator model. So both the generator discriminator we are defining using like Keras sequential API. So we know that how to create the deep learning model. Similar kind of thing we are applying also here. So the generator will use like tf.keras.convolution 2D transpose. So 2D transpose means like you can say deconvolution layer, or you can say the transpose of convolution layer. Like we are doing upsampling. That's why we are applying convolutional 2D transpose here. That means it will produce an image from a seed noise and it will go to the, you can say, low to high, like that. So start with a dense layer and that takes this seed as an input and upsample, again and again, as we already seen this, you can say, we have seen this one like that. Okay, so we will go in this way and you reach the desired image size like 28 cross 1. So notice that like we are using leaky ReLU here. We know that leaky ReLU will definitely help for vanishing gradient problem. So we will use leaky ReLU activation function for each layer, except for the output layer. Output layer we are using 10H. Okay, so we have discussed 10H activation function as well as leaky ReLU activation function. Now first go for the generator model. So we just create call as we previously we know that in a deep learning models, tf.keras.sequential, and we are passing, you can say it's the input layer. The model expect an input vector of size, you can say 100, because we are taking input shape as 100. 100 means like random noise vectors we are considering in case of GAN. Okay, and that time you are just using batch normalization over here, and as well as you can say leaky ReLU over there. Then we are adding layers.reshape. We are considering this, and for assertion operation, we are matching. Like we are considering batch size is none here. We are not giving any batch size, and that should be shape should be rigid like 7 plus 7 plus 256 here. That means the dense layer. That means the input layer will be transformed into a vector of size of 7 plus 7 plus 126. Oh, sorry, 256. That means you can say flatter version of spatial resolution, like a 7 plus 7 grid with a 256 channels. And when we apply batch normalization here, that means you can say it will normalize the output to the dense layer. Like whatever output is coming from the previous layer, it will normalize it and pass it to the next layer here. So it will ensuring stableness and consistent trimming. Then we are also applying leaky ReLU. I already explained that. So leaky ReLU activation function obviously will remove the vanishing gradient problem, and it will give the flavor of non-linearity. Okay, because whatever formula we have, can anyone say the formula of leaky ReLU? I will need the activeness. Yes, can anyone say?
Yes, sir. It is maximum of 0.1x, 2x. We are keeping
Okay.
minimum values for negative so that they are not
0.1x and
0.001 and x, 0.001x or 0.1x, comma x. We take
Yes,
maximum of these two.
we have to
So
consider
the
maximum value.
Yeah.
Yes,
So
yes.
that
Because
positives are given more importance.
yes,
than
because
the
we know
negative.
that the problem with the ReLU, it was
Yeah,
towards the
vanishing gradient problem
Yes.
needs to be solved.
So it will give the flavor of non-linearity. Okay, then simply we apply convolutional 2D, the transpose of this convolutional layer, then apply stride padding, and bias we are using false. Generally, in the deep learning we are passing the bias to each layer. Here we are going for false. Then we can say apply again batch normalization, then again one convolutional transpose layer. Then we will create the generator model. Then we are going with you can say the same as your generator, whatever generator model you have created. So it will create an image. So you have to call it. So we have just given the name make underscore generator underscore model. Now we just pass it to the generator object, can say, and we create a noise tf dot random dot normal 1 to 100, and we generate image by passing noise, and you can say training will be false here. When we show it by matplotlib object plt, and we can get this image. Okay, so it's a initial phase what we get for 100 random noise point here. Then the task is create the discriminator model, because this image will pass to the discriminator. So again the similar kind of thing we are applying, you'll see here, but here we will not do deconvolutional. We are doing convolutional layer here. So before that we are applying conv 2D transpose. But here we will do with the con 2D only. Then similar kind of thing, we apply sequential pattern here, then apply leaky ReLU, then we apply one, the regulation that you can say dropout for 0.3. Then we create the discriminator model. Now use this discriminator to classify the generated images as real or fake. And the model will be trained, you can say, to output positive values for real images and negative values for fake images. So here just understand, because in the PPT I have already said that if you remember, the discriminator, both real and fake images and output probability, and the value between 0 and 1 if we are taking. So 1 indicates a prediction of authenticity or reality, real images, and you can say 0 will be the fake one. So that means it will take like the positive value for the real image and negative values or 0 values for the fake images. Now we are calling the discriminator model here. Then we print the decision. Okay. So when we print the decision, so it will be, like whatever regularizer we have applied, what are the things, what the shape will be there, like that, something it will print in terms of this. So probability will be 0.003357 something. Till now, anyone have a problem? Let me know. Or if you are feeling bored, we can play something. Many apps are there for GAN. I want like you have to learn something. That's why I will do this thing. Yes, anyone? Yes, anyone say something? It's 8:30. The dinner is waiting for you.
Seriously.
Nitin sir, you haven't offered, physically, so you have to, give the dinner to all of them. They are continuously, attending your FDP. So, okay. So again, we will continue. Okay. So I will finish it, like next 15 minutes, because I will not take too much time. It's 8:30. We have started from 7:20. Okay.
Yeah,
So
yeah,
now,
sure.
So now we will define the loss and optimizer. Now define the loss function and optimizer for both the model. Both the model means either for discriminator and for the, you can say, for the generator. So we have already said in the steps, if you remember. Yes. तो कहाँ गया हमारा steps? मैंने समझाया था आपको. Yes. So here we have the steps like define the loss function optimizer, like discriminator loss and the generator loss. So we are going with the, so we are define the loss function. Generally, this method returns a helper function, like we are computing cross entropy loss. You can change the loss when we are using WGAN, so you can change this loss function, but in this time we are using binary cross entropy loss, and we already use it in the logistic regression machine learning, if you already know that. Now discriminator loss, what they will do, this method will quantify basically how well the discriminator is able to distinguish real image from fake. It will quantify as, in terms of, you can say, the total loss. Total loss means like how much, you can say, the entropy for real loss and for the fake loss. Then we will add it. So it will compare the discriminator prediction on the real images, and it will give, to the array of ones. And discriminator prediction of fake images, it will give the array of zeros. So now we are defining the loss function for discriminator loss, real output and fake output. Then we apply cross entropy. We know that how to use it, and we calculated real loss and fake loss, and we added it and return the total loss. So we will get the total loss over here. Now this is from the discriminator side, but we have to understand the generator side also, because they are, the complete trade-off. So we have to go with the generator loss. It will also quantify how well it will be able to, you can say, fool the discriminator. Fool the discriminator means obviously it will get the, input from the discriminator side, and the generator wants the loss will be increased from, at the discriminator side. So that time the generator is performing well. So you can say the discriminator will classify the fake images as a real. So that time you can say the discriminator will fail. Okay, so the compare of discriminators decisions on the generated image to the array of ones, you can say. So we are just apply cross entropy here for fake output, for fake, you can say, this generator loss. Now the generator and the discriminator optimize are different. You can say these both optimizers are different. So what we are doing, we have to apply, you can say we have to train both networks separately. It's not like it's the one network, because we have we have already created the generator model as well as discriminator model. Now you can see here we have to define optimizer separately. So we have defined like Adam optimizer, I have taken 10 to the power minus 4 here. Again, you can pass, that should be a careful value. You can take, 10 to the power minus 5 to 10 to the power 5, any value for the optimizer. So it, depends on application to application. So then you will get the generator optimizer and discriminator optimizer. And you can save the checkpoints for these points later on. Once time you have to go with a hidden trial, but later on you can understand. So that time the optimizer will be set, discriminator optimizer will be set, generator will be set, and discriminator will be set. So these are the checkpoints we have already saved. Now the step number 3. Step number 3 is training loop. तो क्या क्या कर लिया हम लोगों ने? We have set up, यानी हमने TensorFlow cast कर दिया. Then second number पे we have load the data set. Then we have third, we have created the discriminator model and generator model. Then we have set the optimizer for both. और हमने क्या कर दिया इसके पहले? Then yes, anyone? Yes, कोई बोलेगा? Anyone say something? बोर हो जाएंगे.
Hyperparameter pass कर दिए.
Yes.
We have passed the hyperparameter. Sir, is it mandatory to have same loss function for both the discriminator and?
No, it's not mandatory. It's not mandatory. But as we know that Adam optimizer is the perform very well. So that's why we are applying this.
We are keeping Adam for both of them. But it is not mandatory. We can try with other optimizers.
Yes, yes, yes. And as well as what can you do? You depends on your application also. Sometimes Adam will not, work very well. So that time I am suggesting like whatever application you are running on GAN, so you have to read the previous researcher, outputs, whatever. Yes, research paper from researcher side. What type of optimizer they have used.
Okay, sir. Thank you.
So now we check points. Then we are going for third step, training loop. Now again, one more hyperparameter we have discussed, buffer size and buffer, the batch size. Again, the third important parameter, hyperparameter is epochs. We are taking 50 epochs. If we can take 100 or 200 or 250, so what will occur? Again, the training challenge. We have discussed the training challenge in this topic. Overfitting will occur. Okay, so please very careful, attempting epochs also. And then we are, consider here noise dimension 100 and number of examples to generate will be 16. Okay, so you can, reuse this seed over time. So it will be easier for you. And you can, visualize, I can already, show the steps. It will be optional to, generate an animated GIF, so that time it's an optional image. So here we have take the seed, like how many numbers of example to generate, noise and epochs. Then the training loop begin with the generator receiving a random seed as input. Okay, whatever, seed you have defined over here. And seed is used to, produce an image like we have done already here. Previously we have tested. Okay, so now this discriminator is again used to classify the real images. Real images like, what we want from the generator side, that should be matched with the real images. And the fake images like, whatever it will produce by generator. And whatever, training set images we have that are considered the real images. Now, the loss function is calculated for each of these model. Each of these model means both model, generator and discriminator. And as well as the gradients are used to update the generator and discriminator. Please take care for this thing. We are calculating gradients for training and learning. if your gradient will be vanished by second or third or fourth epochs, that means there is something problem in your GAN, something problem in your hyperparameters. So please take care for this thing. You have to understand when your gradient will be there, it is not vanished. That means your loss function is good. Otherwise, you have to change it. Either value you have to change it. So now use TF dot function. Again, we are defining the training steps. We are passing the images, then batch size, noise dimension. Then this is a simple one we have done. We just called it like real image for fake image discriminator model. Then both loss, generator loss and discriminator loss. Then gradients of generator. Please understand this thing. We are calculating gradients of generator and gradients of discriminator. And then we apply the optimizer, applying over the gradient. Then Adam we have defined already there. Now training, here we have defined the training steps. Then we are going for training. Then whatever data set we have, epochs, whatever we have defined, then we calculate. It's up to you, whatever checkpoint you have already saved. Otherwise, you can change it. Okay, and you will generate and save the images as generator, epochs, and seeds. So you can use the same seeds also as a noise embedded in the, to update the generated image or fake image. Then you can go with the prediction side. Then test input will be there. Here training will be false. That time means training is completed. And you can save the figure. You can show the figure. Now call the training method. Whatever we have defined to above the, train the generator and discriminator simultaneously. And please remember this thing. Training GAN can be tricky. So please keep in mind, generator and discriminator should not overpower each other. If they will overpower each other, definitely the learning rate will be similar and overfitting will occur. So please take care for this thing also. So at the beginning of the training, you can say the generating images look like a random noise, as we already seen the the first image. And as the training progress, going like after some epoch like that something, so the generating digits will be look increasingly real. If it will be same as like 1 1 1 1, can anyone say what problem is occurring? We have discussed. If the same image is generating from the generator side, so what problem is going on?
Some mode collapse?
Yes. So we have already discussed this thing. Okay. So please understand, check means you can start with less epochs. Okay. And check your model is working or not. It is going to train or not. Otherwise, it will take time and later on you will get the wrong output. So after 50 epoch, it will be resembling with the MNIST data set. Okay. And you can take like, about 1 minute. And that time you can with the default setting on Colab. Now you can call train dataset epochs. It will look like that. Restore the latest checkpoint. And again, you will do. You can also do the GIF, with this image. So here the GIF will be there. Something. So I have written the code for GIF also. So it is somehow we can say with the GAN experiment, I have shared this one. You can do some changes over that. Apply on other data set. So definitely you will get lot many things. And last, what we can do. So batch normalization, you already know that. Okay. So if you don't know, please read it. It's very, very crucial to handle the challenges because it will, give you the stable model and speed up the training process. That's the problem of, training instability. And cross entropy loss, because whatever we have read in lossy regression, it's a different one. But here we are using discriminator loss as a ungenerated loss. So you can say it will predict whether sample is real or fake. So that time it will be, the cross entropy in GAN. So it is from my side. Anyone, any question? We have 15 minutes. Thank you. Yes. Shivani ma'am, Nitin sir.
Yes, sir. Thank you so much.
Participant,
So,
anybody is
participants, anyone have any question?
Hello, sir.
Yes, yes, Vijay sir.
I have one question regarding the operation of GAN from security privacy perspective.
Okay.
Like, suppose I have image. Sir, first of all, I want to know if I am giving input images to the discriminator, so that must be a huge number of images or limited images can be possible there.
From at the training time, it depends on you, like what kind of application. For example, if you are going for anomaly detection, okay, so that time you have to pass different kind of, the real you can say images where anomalies are not there. So later on you have to train with the real image as well as anomaly images. So it's obvious thing for machine learning and deep learning model, we are passing lot many images because that time the training will be good.
So, in that sense, as my perspective is security and privacy perspective, or you can say terrorist attack, terrorist position perspective. Suppose you want to know the position of terrorist in behind the wall or like that. So, in that sense, we cannot have accessibility to the terrorist. That means we don't have the real image of the terrorist. They may be moving behind the wall, which we may not get. So, in that sense, how the generator will work and how the discriminator is working, or it cannot be possible in case of GAN to have facilities regarding this aspect. If it is possible, then how it is possible?
Yes. So number one, what we are saying in the PPT, I already said that it will work on unsupervised learning. So unsupervised, we don't have supervisor. That means we don't have the target label. So the similar kind of thing we are, applying in this your application. We don't have the real image of the, you can say, the terrorist, but we have the features. You can say they have a gun or some kind of their speed or their infiltration technique, some kind of tools they are handling something. For example, at the border side, border security force, suppose someone is just taking one ship or boat in their lap, but someone is carrying one object look like a gun. So that time you can easily understand that like it will be a harmful object over there. So in that case, similar kind of training you can give to the GAN, and it will definitely work for those applications also.
So, what about the sir? It's about discriminator training. What about generator training? It will be done automatically through noisy data.
Yes, but you have to understand. I have. Should I share the PPT also again? Wait a minute. Yes. So I have already shown the, Yes. So is it visible? The structure
Yes,
of GAN. So
yes,
here
sir.
you can see the real image is passed to discriminator. Okay. So that time real image means like suppose you don't have. So that time this kind of attribute you will pass to the discriminator and it will feedback given to the generator. That time generator will improve the, the fake image. That will be look like real image. So that means whatever attribute we have, which will pass to the discriminator side, generator also try to match with those attributes.
Yes, sir. So in that sense, among discriminator and generator loss, we should be having less discriminator loss because we want to get the appropriate position or the localization of the target or terrorist like that.
Yes, you can say there are different kind of thing. Number one is object detection. Second is object recognition. Third is object localization. So we have to take care of those three aspects. Which aspect we are working? If we are going for object recognition, that means, for example, we are identifying the terrorist. So that time you are focusing on recognition side. So you are, you have to give different occlusion over there also. as well as, you know, the blurry image also. You have to give the, you know, dark image also, and different kind of attribute also. Hope you understand.
Yes, sir. Yes, sir. Thank you,
Yes,
sir.
sir. Okay. Any other? So I have shared my
Anyone else?
yes, yes.
Yes, sir. You were talking
Yes,
about
sir.
W. Sorry, Shivani ma'am. I had a
Yeah,
question now. So you were talking
You
about
carry on.
WGAN.
yes.
Now, how it is better than GAN, sir? How it
They
basically
have changed the loss
improve?
function.
So what loss function is being used in WGAN, sir?
No, no, they have defined. Okay, I just show one paper also. I forgot to show. Yeah, wait a minute. There is a, you know, paper. My screen is visible to everyone.
Yes, sir.
Yeah, those who are
Yeah, yeah.
working with GAN, it's a very, you know, relevant paper for all of you regarding my topic. So this is, you can say, in archive. So generative adversarial network. So here, those who are, you know, just start GAN. So it will give you the idea, the concept, and the different advantage as well as the loss functions over here. I have used some images from here. I have already given the credit in the, you know, PPT. So you can understand whatever we have discussed here. Okay. Then they have proposed one method, that is improved GAN architecture. Okay. So they have used like as we know that we have a supervised, unsupervised, and reinforcement learning. So they have used semi-supervised, you know, GAN here, then conditional GAN here. So my suggestion is, whatever model, because in this time, you know, WGAN is older than in the recent approaches. In this time, the number of variation is already done in the loss functions. Someone have clubbed 2 loss functions, someone have clubbed like ensemble learning, we know that. So similar kind of things they have applied over there. Number 2, like I have applied, you can say, leaky ReLU activation function all for all the convolution layer. Have you noticed this thing in the MNIST data set?
Hanji,
But
sir.
but it's not fixed. You can use leaky ReLU activation function as well as number of activation function which are clubbed with different loss function also. So my suggestion is, yeah, so you have to just go with the recent research, or the previous also last 2 year research is a 2022 paper. So that time you can understand what changes they have done. So here they have also given the architecture also for different GANs. Okay. So here
Okay, sir.
WGAN is there. Yeah, you can see this is, you know, like they have used like when it solved the vanishing gradient problem, I have told you, and you know, the collapse problem. So you just check like with the earth mover distance. Now you can see they have just changed the earth, you know, earth mover distance they have used, and whatever we have seen in the equation 1, when we are going with the equation 1. Okay. Hope I'm not taking too much time. Yes. So this is equation 1, and they have changed that, you know, the distance, because the GANs are optimized using mean max optimization problem. Okay. So the similar kind of thing you can solve with, you know, least square method also, or by Lagrangian method also. So the way of solving the objective function, as well as what kind of penalty you are applying on those objective function, that also create a new model. Hope Sadhana ma'am understand.
Yes, sir. Yes, sir. Thank you so much.
So I will
Please
share this
share
paper.
the paper. Yes, sir.
Yeah, I will share this paper also.
Okay, sir. Thank you.
Any other question?
Hello.
Yes, yes, ma'am.
Yes, sir. Sir, can you tell that what is the current national and international status for the GAN work?
I will not be sure what for your national or international, you can say. I will not be sure, so I will not take that question.
Okay.
Okay. One more question from the Sana Afri ma'am. How to tune hyperparameter and what optimization technique should use?
Yeah. So it is similar kind of thing कि मुझे साइकिल चलानी है, मैं बिना हाथ छोड़े साइकिल कैसे चलाऊं? You understand this question? So it is like that, like, for understanding the application, then what kind of previous work already done by, many researchers in the same application, that will help you to decide the hyperparameters. That is answer.
Okay, sir. Thank you. Anyone have any question?
Dear
Anyone?
participants, anyone have any question? Please ask. No questions?
So when you ask the question, that time I can test myself also. So that's why I said to everyone, hope, I will also, learn something from your side. You will ask the question, like as one man ask the question from the national international level. Definitely I will search it out, this thing.
Okay, I think no any questions.
Okay, so it will better everyone can open their camera, so at least we can take one snap. Nitin sir, you can take if you want. Those
Please
those who
open
are
your camera.
those who are
Those
can open
you
the
are
connection.
able
Yeah,
to.
those who can open. So Nitin sir, you can take the snap if you want.
Yes, sir. Shivani ma'am.
So I will share this PPT also with the Shivani ma'am and Nitin sir. So participant, you can take.
Yes, Midi ma'am.
Yes, sir.
Yes, just take the screenshot.
Okay, sir.
Okay, thank you so much, Umesh sir.
Thank you.
A
You too
wonderful
also, you
session.
invited me for this talk. Hope I have worked for some of anyone also at least.
Definitely, definitely, it was good. And the last, when you just implement a code on a collab, so that is very beneficial to all the participants.
Okay.
Yeah. Believe
Okay.
and continue.
Thank you, sir. Thank you so much. I would like to extend our sincere gratitude to Dr. Umesh Gupta for delivering such an insightful and enriching lecture on training challenges in GENS. Your expertise and thorough explanation of the complexities of GENS have truly deepened our understanding. We appreciate the time and effort you took to share your knowledge with us. It was an honor to have you as our speaker, and we look forward to future sessions with you. Thank you once again, sir, for your valuable contribution. Thank you, sir. Thank you so much.
Yeah, thank you, Millie ma'am, and thank you, Nitin sir and Shivani ma'am. And we will meet on last day because I
Yeah,
have another
definitely.
talk in your FDP for
Yeah.
image generation. So those who
Yeah.
are interested, I will try to run some program for image generation also. So we
That's
will also experiment with some app also. Today I have missed the experiment for app because it's a topic is very, theoretical training challenges.
definitely, sir. Definitely.
Okay, thank you.
Okay, thank you.
Okay,
Good
sir.
night,
Thank
sir. Good
Shivani ma'am, please share the attendance link as well.
Yes.
you.
Okay.
Thank you,
Good night,
sir. Good
everyone.
night.
Thank you. Thank you so much, sir.
much.
Okay, for all the participants, there is some announcement. We will share the tomorrow's session link on the WhatsApp group as usual, and attendance link only be shared in the chat box at the runtime. Maybe Shivani ma'am this time. Hello, Shivani ma'am.
Shivani ma'am already shared, and we are also go through the WebEx attendance.
Okay.
So
Okay,
WebEx
sir.
is
Okay, sir.
automatically take the attendance, and we can check from that place. Okay.
Yeah. Okay, sir. Okay. Thank you, sir. And we will meet tomorrow for other interesting sessions. Good night, all of you. Thank you so much. Thank you, Nitin, sir. Thank you, Shivani, ma'am. Good night,
Thank
all
you.
of you.
Thank you. Thank
Thank
you.
you.
All may leave
You
the
all
meeting.
be, okay. Okay, sir.